So this is, we've done chi-squared goodness of fit. This is chi-squared test. You can actually do the chi-squared test for those TI-83 folks. It's a little tricky when you are looking at a goodness of fit. It'll do both. That's why the 83 doesn't have it. So we're looking at with the TI-83 or 84, but if you've got the older one, you're in good shape today. Chi-squared. I'll go over the difference here in just a second, but the degrees of freedom are calculated a little bit differently. It's the number of rows minus 1 times the number of columns minus 1, or R minus 1 times C minus 1, which frankly is no different than goodness of fit. It's just that with goodness of fit, you only have two columns. You have an L1 and an L2. So what's 2 minus 1? That's 1. So it's the number of rows minus 1 is what they say for goodness of fit. But it's really the same. Where chi-squared is different, where goodness of fit will only allow two columns, chi-squared will allow as many columns and as many rows as you want. So there's no limit to the number of rows and columns in chi-square. So what are we testing for? I'm sure that's on everybody's lips, right? Testing is the only thing you can do with chi-square. Is there a significant difference in one or more categories or groups? Not between, in. Sorry. That's what we're testing for. Right on that stack. Now, we can't use a bunch of lists in this case. We're going to use something that we haven't used in this class before, but hopefully you've experienced before. We're going to use a matrix. And if you haven't used a matrix before, or if it's been a while, what you have to do in the calculator is you hit second and the X inverse key, which is just below the math key on the left. And we will build matrix A for the observed group. The cool thing is the calculator actually will calculate the expected for us. So we don't need to make the expected. The expected is created by some mathematical magic in matrix B. You do not need to calculate it. So I think that's really what I want you to know about chi-square. Other than it having an unlimited number of rows and columns, in goodness of fit you have a limited number of rows, a limited number of columns, 2, and an unlimited number of rows in goodness of fit. This unlimits you in both directions. So it's a large array, if you will. Example. Let's look at an example. This is not in one of the problems in your book, so we'll have to put in a little bit of information. A survey of 490 college students at a Southwest State University bless you, consisting of freshmen, sophomores, juniors, and seniors, were asked if they had body art. That doesn't include Sharpies being marked on. Sharpie doesn't count. Something permanent. And given that alpha is 1%, we want to know if there's a significant difference between them. So here's the information that we have. Grade. If they have piercings, a tattoo, both, or none. So we'll start with the freshman. The freshman, 61 had piercings, 7 had tattoos, 14 had both, and 86 had none. Just out of curiosity, we don't need it, but if we were totaling up this row, what would I have to do with these numbers? Is there any overlapping here? So I guess the question is, for you guys, are the people who have both, are they counted twice? Yeah, it doesn't appear so because the tattoo is less than both, right? So if you were getting the total, you'd have to add all these guys up. You always want to watch your numbers and stuff like that to be careful that people aren't being counted twice, but the total would be the sum of all those. All right, sophomore. 43 had piercings, 11 had tattoos, 10 had both, and 64 had none. Junior, 20, 9, 7, and 43. And senior, 21, 17, 23, and 54. So with chi-squared, everything that we've learned about chi-squared, there's two groups of numbers that we need to know about, right? Which one is this? Observed. Yeah, exactly. This is the observed. I thought I had a pen here that was a different color. Right, these are our observed values. Now, the null hypothesis here is going to be that there's no difference between the proportions of students in all of these categories. The proportion of freshmen equals the proportion of sophomores equals the proportion of juniors equals the proportion of seniors. What's the alternative? With chi-square, what have we been testing against all this time? Yeah. Right, there's a difference in at least one or one or more, yep. There's a difference in one or more proportions. Okay. We're going to go to the calculator here in just a second, but let's calculate our degrees of freedom. Excuse me. For our degrees of freedom, it's going to be the rows minus 1. So how many rows? 4, right? There's 4 rows minus 1. So that's going to be 3. Times the number of columns minus 1. That's also 4, right? So 3 times 3 is 9. All right, I'm going to see if I can get the... Now we'll jump to the calculator here and see how to do this. Okay. So what we need to do is we need to put these numbers into a matrix, just as they are. Now, to do that, I'm going to go to second, and then matrix is just below math, so that inverse of x. And I want to go to edit. So second, inverse of x, and then edit. And I want to edit A. So the first thing I want to do is I want to make sure that the dimensions are right. So it's always rows times columns. So in this case it's 4 for each. So I'm going to change it to a 4 by 4. If it's not already, yours might already be set to 4 by 4. And I need to put these numbers in. Now when the numbers go in, they go in each row first. So as you're hitting enter, it's going to be going across from left to right. So 61 and 7 and 14 and 86 and 43 and 11 and 10 and 64 and 20 and 9 and 7 and 43 and 21 and 17 and 23 and 54. Make sure your numbers are in correctly. Let me know when you're ready. You got it? We do not need a expected. That's going to be created for us. So I'm going to go ahead and quit that. Oops. And go to stat. It is one of our tests. Chi-squared is one of our tests. And it's down towards the bottom, so I'm going to go up. It's just the chi-squared test. And it asks you, where is your observed? It'll probably say A. It's probably already saying that. And the expected is basically saying, where do you want me to store the expected? B is just fine. And we'll calculate. And so we have very little to write down. So the chi-squared, so this is the chi-squared test. Chi-squared equals about 29.5. the p-value, I'm going to put it in decimal form, about 0.0005. And degrees of freedom we already have down, but the calculator confirmed it as 9. So, can we answer the question of the alternative? Did we discover that there was a significant difference in one or more of the proportions? Yes, right. P-value is very low at any reasonable alpha. So we have significant evidence at any reasonable alpha to conclude that there is a significant difference in one or more of the groups. Okay. Okay. That your conclusion, I'll let you fill in the conclusion. But let's go back to the calculator here for just a second. Let's have a look. What if you have a question that asks you about your expected? Instead of calculating it, go ahead and do the chi-squared test with a matrix. And then what you can do is you can go back and you can look at, by going back into the matrix, I'm going to go second and the inverse of x. And I want to edit is the easiest way to look at it. And I'm going to choose B. And there you go. There are your expected values. They don't need to be calculated. It does it for you. Which is sweet because in chi-squared you have to, goodness of fit, you have to calculate them. Cool. All right, so let me give you some heads up on a couple of problems. I think there's only 4 today. They're pretty meaty. At least one of them says, calculate the 8 individual chi-square values. I don't want you to worry about that. In fact, by not doing that, there's a fair bit of a question that you'll not do. Okay, you'll skip that part. Because by calculating the chi-square values, it'll tell you which one is more significant, you know, which category. But I am going to maybe suggest that if you're planning on taking the AP test, maybe look at that. Remember that's observed minus expected squared divided by expected. You can get your expected values from the B. So, but for the rest of us, don't worry about that.